Okay. Are you guys ready to go? You guys all pumped up after the keynotes this morning? Some pretty awesome stuff. First of all, I wanted to thank you guys for coming to the Build conference today, and also thank you for coming to this session. I will do a little bit of slides up front, but for the most part, I have, I think, 9 demos that each have 5 or 6 parts. So this will be an extremely demo-filled session. Some of my demos were failing this morning, and we got a backup machine. So I'm on the edge of my seat to see if this will actually all work. We do have some backups, so I don't think you should be worried. We will be able to see everything. I just might need to hop between machines a little bit. So first of all, let me introduce myself. My name is Amanda Silver. I'm the Director of Program Management for the team that works on client applications within Visual Studio. So that actually covers any tool for building an app for Windows applications across all of the different Windows devices, the native XAML experience, things like that. IE, so the F12 tools that you guys might have used in Internet Explorer, now Edge. That is also on my team, as well as the TypeScript programming language and the tools for Apache Cordova. I also work very closely with the Xamarin team, and so I will be demoing some of that stuff for you today. So that kind of covers who I am, and we will kind of jump right in. Please do submit an evaluation. This actually does help me going forward for future talks so that I can improve each time. But let's kind of jump right in. So the first question is, why build apps? How many of you guys have built a mobile app so far? Okay, not everybody in the audience. And in fact, I have had the opportunity to talk to 60, 70 companies in the last 3 to 6 months, having conversations like this about different strategies for building mobile applications. And one of the things that I'm finding across all of the companies that I talk to is that a majority of them are at the knee of the curve in terms of embracing mobile technology and building mobile solutions. And what I mean by that is that they have built 1 or 2 or maybe 3 mobile apps thus far, and they might have done it by hiring a mobile specialist firm. So they actually outsourced the project to another external company to build this mobile app. And they're now in the process where they realize that, hey, I actually think we have 10, 15, in some cases, hundreds of mobile apps that we have to build now. And we actually need to bring this in-house and make it more a central part of our practice. Does that kind of reflect where you guys are, any of you? Yes? No? Nods? Yes? Okay, I see a couple of hands in the back of the room. The other thing that I'm finding as I talk to, in particular, small ISVs, so think about it as startups who are building applications because they want to have a mobile app-based business. For them, they really want to get a mobile app out to market as quickly as they possibly can so that they can basically build a min-viable product and test the business model and see if it's actually working with customers. Get that out there, and then actually refine and so on and so forth. And so I think we're finding that there are a lot of companies that are now in this knee of the curve where they are they might have dabbled in mobile development to start, or they've even assigned a SWAT team within their organization to go build some mobile apps. But they're now starting to make that a much larger part of their regular IT practice and development practice. So one of the things that I've also seen, and I think Gartner and Forrester and a bunch of the analysts also reflect this, is that the technology is moving much closer to the customer. So in terms of, what your job is as a developer, it might used to be that a lot of developers had to just build internally facing, employee-facing applications, and they didn't actually really interact with the customer very much. I would say that more and more often, I'm seeing that actually the internal IT departments actually have to build mobile applications that are customer-facing, and they are much more engaged in that process. Now, many of you guys have probably been in development for many years, tens of years, possibly decades. And I think that a lot of us, when we started in the industry, were very used to the client-server kind of technology and this notion that we had a user interface and we had some kind of back-end system that we were pumping all of that data in. And in fact, if I think about governmental agencies, for example, a lot of them are still doing that process with a paper process. You fill out a form, and there's somebody who's in the back office who's actually uploading that to a server. And that goes into a database that we would call a system of record. So it basically catalogs kind of what has happened with that particular employee or customer. But there's very little authentic interaction between the developer and what they've built and the customer or the person who is interacting with that workflow process. What we're certainly seeing is that there's an increasing number of people who have to build these systems of engagement. And I think about this with two good app examples. One, my favorite one, is the Krispy Kreme Hot Light app. How many of you guys are familiar with that app? Came out a couple of years ago. I love this app. Not because I'm a big donut eater, although I do like my donuts, but because the idea behind this app is that if you're a trucker driving down the road and you want to get a hot donut, this will actually send a push notification to your device to tell you there's a hot donut nearby. Come to Krispy Kreme. And they did it initially as a marketing exercise to see if they could actually have more interaction and engagement with their customers. But over time, they found that this was actually a very strategic application for them, and that it actually was something that they needed to kind of incorporate and improve, and they wanted to get a lot of that data. How many of you guys are staying in hotels right now? Those of you who are not local. So hotels, on my way down, I was flying Virgin America, and they have those nice little TV screens and a lot of commercials that come up in front of you. Probably 3 or 4 of the commercials I was watching were commercials for the hotel's app. Now, why would the hotel want you to download their app? The way that they marketed it in the commercial was that it delivers a much better consumer experience, and it does. You can interact with the concierge, you can reserve room service or other things like that. But the hotel also gets a lot of insight into what you do as a customer. And so increasingly, we're seeing that people need to build these systems of engagement. And so that's really how I think about mobile applications. So the first question is, when you start building a mobile application, where do you start? Now, one of the things that I think we've observed is that basically, there are a lot of mobile applications that you're going to end up building. If I build something like that hotel concierge app, there might be a reservation system, a room service system, all different kinds of workflows and processes that I would want to interact with as a customer. And each one of those could be an independent app. They could be consolidated into a single app. But the idea is that if you build those services and workflows and processes, and you basically make that really solid, and you get the DevOps practices running very well against that, then you can actually let 1,000 flowers bloom. You can actually let a lot of websites or mobile apps get built against those back-end services. So I think a lot of people in the industry are kind of recognizing that really it starts with the back end. And that's kind of where I'm going to start. So in terms of building these back-end services, we call them microservices, in Azure, as of about 3 or 4 weeks ago, this was basically what we had to offer. Websites, you could build mobile services, you could manage your APIs via the API management services, or you could use BizTalk services. On March 23rd, we basically consolidated all of those things into the Azure App Service. And so now there's one service that will allow you to build a web application, a mobile application, an API app, and a logic app. A logic app would be for a workflow process. So now let's get into the front end. There are basically 2 different strategies that we see people taking when it comes to building mobile applications. Number 1, they start with building native platform technologies, native apps, using the native tools for each of the devices that they target. And so they get full access to the device capabilities, they get fantastic performance for those apps if they continue to tune it, and it's very customized per device. On the other end of the spectrum, we see people building from web technology. So they start with a website maybe, and they might optimize that website for mobile experiences, but still be contained into the browser. Now, the challenge with native-based solutions is that if I target iOS first, I then have to do a complete port and build it using the native tools, ADT, Android Studio, to target Android. And then for Windows, I then have to do it again. The challenge for web technologies is that especially if you're building for a browser container, you're very much constrained to what that browser container is capable of. And so you can't really access the native device capabilities. And so from our perspective, we recognize that this is where a lot of people are coming from, but we don't think that you have to be limited by those constraints. So there are a lot of people starting with rich experiences. On Windows, that starts with .NET or C++. You can also build a native Windows application using JavaScript. But for desktop applications, you would start with WPF or the Universal Windows apps, Windows Universal apps. And with C++, you could build with Win32. But if you wanted to take that .NET expertise, we've partnered with a company called Xamarin. I see many of you guys have Xamarin t-shirts on in the room. That's great. How many of you guys have heard of Xamarin before? Most of you. OK, so I'll show you guys a quick demo, but some of you still haven't seen it. And then we've also introduced new tools for Visual C++ for cross-platform development. And Ankit, who's up here, has a session that will go deep on this. I will show you a number of demos as well on this. For the breadth of devices, if I start in the web space, it starts with the browser-based applications. But what we have been working on over the past year, we announced it at TechEd last year, is the very early alpha of the Visual Studio tools for Apache Cordova. I'm very excited to announce that today we have reached RC for Visual Studio 2015. So now we have a Go Live license. You can actually go ahead and build production-ready apps using the Visual Studio 2015 RC using the tools for Apache Cordova. And I will go into a bit of what the tools for Apache Cordova are. But first, I'm going to kind of jump into demo. So before I show you guys Xamarin, I'm going to show you the Azure App Service real quick. Let me see, which machine am I on? OK. So this is the Azure App Service. You guys can actually go and hit this now and try the Azure App Service. And this starts with you can actually select an app service. We're building mobile apps today. So I can go ahead and create this app. Now I need to log in. I didn't do this earlier, but I'm signing in with my MSA, my Microsoft account, but I could use the other accounts, as you could see. And then that actually just creates an Azure service on the back end that I could then connect with a mobile application. And if we go here, you can actually see that the app service is already up and running. So the apps that I'm going to show you today, we've already gone through this process. The cool thing about this is I can also see it and edit it using Visual Studio Online Monaco. But this is basically the same technology that the Visual Studio Code that we just announced in the keynote a minute ago. It's using the same exact technology to connect to this backend service and show us the code here. I'm sure there are a lot of people hitting this service right now because we just made the announcement. So that might be why it's a little bit slow. But you can see I can go into the controllers, and I can look at something like the to-do item controller, and I can just start, editing this code immediately and start working against the backend service. So, next thing I'm going to do is jump into the apps itself that I'm going to kind of bring you through. This is number 4. So, you guys see before you multiple mobile devices. Yes? Everybody can see OK? OK. So the basic scenario I'm going to show you is like an Uber-type scenario. The idea is that we have a shuttle application that is a corporate shuttle service. And we have 2 different apps. We have an app for the consumer, and then we have an app for the drivers. Now, let's just bring up the myshuttle.biz for each one of the apps, for each one of the devices. And as you can see, the layout for each one of these apps is actually distinct per device. Now, this is a consumer app, so I want to make sure that my consumers that interact with this app in the App Store get what feels like a very native experience for their app. As you can see, for the Windows device, this is Windows 8.1. So I will show you guys a Windows 10 mobile application in just a second, but this one was authored using 8.1. You can see that we have the pivot control. If we look at the navigations, you can see that the navigation looks very Windows-like. If we go to the iPhone application, you can see that the navigation is along the bottom, which is a very iPhone kind of way to do it. And for the Android application, you can see the navigation is along the top. Each of these looks and feels very native for the device. If we look at the transitions for the iOS device and the transitions for the Android device, it comes in from the side for the iOS device, and it comes in from the bottom for the Android device. So it is a very native look and feel. And this is built using Xamarin, this particular application. Next, what I'm going to do is go ahead and show you guys the driver version of the application. So let's just bring up the driver version. So this is basically the cabbie who's driving the car. What does he do when he wants the user to, we start a ride? So we could go ahead and start a service here, start a ride, and we can finish that. And you can see that I get the map information. I can go to the signature. I can go ahead and sign this. My nail was getting in the way there. But that actually takes that invoice, posts it to the Office 365 APIs, which there are a lot of sessions on throughout Build, and then it posts it to a SharePoint server in the back end. Now, so what you'll see here is that the app looks and feels exactly the same across the different devices. Now, for this app, because it's for the employees, my employees of the My Shuttle service, I want that app to have the same look and feel across the different devices because of training purposes, because of support purposes. I actually want to keep the costs down for this particular device, particular app. So for this one, we're using tools for Apache Cordova. Now, if I go into the My Shuttle Biz app again, and I go ahead and request a ride, you can see that that sends a push notification using the Azure App Service, the mobile services, to my Android device. If I go ahead and accept it, you can see that this will actually send another push notification to my Windows device. I can even go ahead and update the location. So you see the pin on the Android device there. I can update my location. You see that it updates right there. So this is a very kind of live experience. That's off screen, but as you can see in just a second, it should show us the pin being updated. So this is using SignalR, which is a part of ASP.NET for real-time communications. So now let's jump into how this application is being built. If I notify the client that I'm here, we can see that the vehicle has arrived, and then I can go out and get the vehicle. The driver allows me to accept it, and then we can go ahead, take the ride, send the signature, accept, and it gets sent to the back end with an invoice. So now I'm going to take this Android device, and I'm going to attach it to this PC that I have here. And I'm going to show you the applications that we built. So let me close this, and let's jump to 7. OK. So first thing, Visual Studio. This is a little bit dangerous to do in a demo, but I actually have setup running here. And the reason I have setup running is for those of you who have built mobile applications, you guys know that it's very challenging to get your dev box set up with all of the dependencies that you need to build mobile applications. For an Android application, I could end up having 20-something dependencies that I have to install uniquely. So what we've done is we've actually simplified the acquisition experience and the dev box setup experience into Visual Studio. We've consolidated it. And so what you can see here is that under the cross-platform mobile device mobile development node, we have Xamarin if I want to build it using C# and Xamarin. We have HTML, JavaScript if I want to build it using Apache Cordova. We have the cross-platform C++ components. And then we have common components that are used across all of these different solutions, including the Visual Studio emulator for Android, which I will show you guys a little bit later. But this is just to show you guys that it makes it really easy to get your dev box set up and to keep that dev box running and in good condition. So I'm going to go back, and I'm going to just cancel setup so that I don't hork my machine further. And now I'm going to jump into the solution. So with the Xamarin extension, I will start with the native applications, so the Windows, the Android, and iOS applications that I built using Xamarin. With the Xamarin extension for Visual Studio, which is now included as part of Visual Studio Setup. So you don't need to go to some other URL to go find it. If you just install Visual Studio as part of Setup, you will be able to check Xamarin. I now have templates for Android applications. I also have templates for iOS applications as well. So I can target iPhone or iPad. So I've already done that in my solution. Now, what we start with is a common core of logic for the application that is built in .NET that works across all three of the different mobile operating systems. And that is done using portable class libraries. What you can see here is that things like the service agents, can you guys all see that? The service agents are defined in a common way. So if I think about something like issuing a ride, I want to initiate a new ride. That doesn't need to be different across the different devices. That could actually be the same exact code running on each of the clients, but it's authored using .NET. The other thing that you can see here is that the view models, even the view models. So if I think about something like the vehicle detail view model, this is basically defining a common view model that is common across all three of the different operating systems. And then we really have only the thinnest presentation tier that chooses how it should be rendered for each one of the devices. And in fact, true story, as of 3 days ago, we didn't have a version of this app for Windows 10. We built it 3 days ago. And the way that we could do that, and I'll show you guys this in just a second, the way we could do that is because most of the logic was defined in these portable class libraries. So next thing I'm going to do is just show you guys how you can actually do this with the portable class libraries. If we go to the properties, you can see that with the Xamarin extension, I can create a portable class library that can go across all the different Windows devices as well as Android and iOS. What's missing there is Windows 10. That does not mean that your portable class library will not work on Windows 10. It actually works. You just don't have to check a box to get it to work. We will add the checkbox just in case, between now and when we RTM the product. So this is outstanding work for us in Visual Studio. But that's basically how I can define a portable class library across all of these different solutions. So now what I can do is go ahead and view the code map for this assembly. And so this is a new tool in Visual Studio 2015 that allows me to quickly visualize what's going on in my application. And I can look at the assemblies referencing this. This is actually going to build this up dynamically. And you will see very quickly that each of the projects that are in the solution are referencing this core DLL. And it will show it to us in just a second. Come on. Indexing. This does take a little bit to compute, but once you do, it's pretty amazing what you can see here. Come on. This was faster earlier. Yeah. Portable class library, yeah.
Does that mean that you're limited to the DLL reference to whatever it goes?
There is a subset, but it is a pretty broad subset. It's actually Oh, sorry. The question was, and we now see it coming up. The question was, because it's a portable class library, do you have to limit the APIs that the portable class library can access to make it a portable class library? The answer is yes, but it is a very, very broad subset, and we are working with the Xamarin community and the open source.NET community to make sure that that's as broad as it can be. We think it's pretty good, but we're always looking for those last few APIs that are kind of important. So if you have feedback on that, feel free to give it to me. As you can see here, I have, for the native applications, I'm referencing the myshuttle.client.core DLL in the universal app for Windows 8 and 8.1. I mean, Windows 8.1 phone and Windows 8.1 in the Xamarin Forms application, and then the iOS and Windows 10 universal application. And then I also have a WPF client that I've also built against this same portable class library. I'm not going to talk about the WPF client today, but that will be in the solution that we make publicly available. Now, if we go into the native mobile applications, you can see that for the Windows 8 and 8.1 applications, what we've done is we have different projects, but we have shared projects, shared code across these different projects. So if I go in here, you can actually see that if we look at the about.xaml file, you can see that this will just take 1 second to load, but you can see that I can actually use the same exact XAML file across the Windows and Windows Phone device. Let's just make this come down. And so I can actually go ahead and change that to be a Windows Phone rendering. And you will see in just a second that that will re-render for the Windows Phone. And you will see that it's basically the same exact screen and same exact XAML being shown across to the Windows Phone. Now let's talk about the Windows 10 application. So in the Windows 10 application, we can do basically the same mechanism. If we go into the views, we can look at the vehicle detail page. And as I'm doing that, so as you can see here, we are currently rendering this for the 5-inch phone. This is all new functionality in Visual Studio 2015. I can then go ahead and change that same view to look at the tablet. And now this is only at 33%, so if we increase that a little bit, you guys should be able to see what it looks like in the tablet view. And what you can see here, what you should be able to see here, is that we actually can use various view state triggers to basically initiate this. What I'm going to do is just show you guys it running in the phone emulator and the Windows simulator side by side. So this is that app running side by side. As you guys have seen previously, in Windows 10, all applications, including modern applications, are windowed. So this will start initially in a windowed mode, but I can make it go full screen. And as you can see here, one of the benefits of developing on a touch device is I can actually use my finger here to scroll to the bottom of the available cars, and I can see the My Rides tab that is on the tablet view. It's actually on the right-hand side. And then you can see if I select this, you can see what the vehicle detail view looks like, and you can see what it looks like in the phone. So we built this 3 days ago. Yes, we could make the UI a little bit better, but you can see that we're actually using the same kind of technology for the Windows devices. Okay, so that's the Windows applications. And there are going to be a lot of sessions, and in fact, Joe Stegman is here, and I think he will be talking about this a little bit later, on how you can actually customize your XAML across the different devices. So I'm just going to shut this down. Okay, now let's jump into the Xamarin portions for the Android application and the iOS application. So first, I'm going to kind of look at the Android application. And if I go into Views, Main View, and I just start typing, you can actually see that I have IntelliSense here, based on the Xamarin extension, that gets me the latest Android capabilities. So I get all of the same Visual Studio productive development experience, but for Android and iOS applications. So that's pretty great. Next thing I'm going to do is show you the vehicle detail view, that same screen that we just looked at in the Windows application. And I'm going to bring up the Xamarin Designer. Now, after this renders in just a second, let's close it and reopen it. You can see that this is kind of what the screen looks like for, in this case, the Galaxy Nexus. If I went ahead and changed this to the, let's see, Nexus 5, you will see in just a second that it'll re-render for the Nexus 5. So I get a WYSIWYG kind of experience for building these screens for Android applications. I can change the layout, for example, change it back, and you can see that that happens. Same goes for the iOS application. So if I go into the iOS application, you can see that this is using the MyShuttle. It's using Sirius.mvvm cross, so that's a common MVVM library. This is using the MyShuttle.client.core, as we talked about earlier. And then if I go into the views, the storyboard view, you can actually see that I get the same kind of WYSIWYG experience. We have a full toolbox so that I can do drag and drop all kinds of controls onto this design experience. And in fact, for iOS, it's not just a per-screen designer. This is actually a full storyboard designer like what you see in Xcode. So if I zoom out, you can actually see that I have the full storyboard for the application defined in Visual Studio for my iOS application. So that's pretty cool. Cool? Is this what you guys were kind of interested in seeing? Okay, so the next thing that I'm going to show you guys is we're going to do a deep dive into the C++ stuff. Before, let's see, how are we doing on time? How do you guys feel about skipping some slides and just keep demoing? Good with that? Okay, if we have slides time at the end, I'll go back to the end. Okay, so the next thing I'm going to do is just shut down this project and reopen another one. I can't have all of these things running at the same time, unfortunately. Just gets it too clogged up a little bit. If I had a full beefy desktop machine, it would be no problem, but this is a lightweight Asus tablet. So next I'm going to open the C++ version of the Xamarin project, and I'm going to deploy that same application. So I talked about earlier how we have also introduced support for cross-platform C++. Now, how many of you guys code with C++? A lot of you guys, okay. And one of the reasons why we did this is in talking to our Office team as they were taking their code base, 20, 15-year code base, to mobile devices across iOS and Android. They basically needed to take that code base mobile. And so we started building this for the Office team. What you can see here, if we look at this application, this is all C++. If we go into the project properties, you can see that Visual Studio supports Clang, and it supports GCC. This is a new world. So this is kind of a big deal for those of you who have coded in C++ before. So I'm just going to keep that there, and I'm going to deploy this to the Samsung device that is attached here. Now, what this is doing is it has a common C++ component, and in this case, it's an OpenGL component that I'll show you guys in a second, that is being used in this application. And then it has a front end that's defined using Xamarin. And so this should be deployed to this device in just a second. And it's copying the application to the device. I will jump to the Wolfavision thing as it does the installation, and it should get loaded in just a second. So what we're going to show you guys in just a second is an OpenGL experience. As I request this car, you can see that this is actually OpenGL defined in Visual Studio running on the Android device with the Xamarin front end. So once that vehicle is requested, we're good to go. Okay, so now I can jump back to the demo. I'm going to show you another application real quick. Let's stop debugging. And I'm going to show you the Bing Maps control. So let me go into here. We will debug Bing Maps. So this is the real-life Bing Maps control that the developers at Microsoft have built. And I will show you that running on the device in just a second. So what we've done here is we've taken that application. We have not modified it. So we've really just taken that application. But what we have done is we've created a small wrapper, which is a Visual Studio project that is wrapped around that C++ project so that I can launch it and deploy it onto the device and actually attach the debugger. So if I go ahead and just press play, we can go ahead and deploy it to the device. And what this is going to do is it's just a tester for the map control itself. So if we jump to the Wolfavision, let's see. Can you guys see that? On the Android device, it's loading now. It's in the process of loading. And it's loading symbols here. So if we come back to this, you guys can see that it is set 7. Still loading symbols. It's attaching in the debug mode. And now we can go to the Android device. And you can see that it's loading. It's in the process of loading the map. If we go to Seattle, this will take just a second. You can actually see the Seattle map getting loaded here. I can pan around. You can see I'm going back to Seattle. So you can actually see that native C++ component is running and debugging. Now I'm starting to load the rasterization images for the traffic control. And if we go back to 7, you can actually see that I have hit a breakpoint here. If we go ahead and hit F10 a couple times, let's see. You can see that the stepping is actually pretty fast. So we're using GDB on the back end to do this native stepping as well. All right. So now I've talked about the Android emulator before. What I'm going to show you next is, again, a C++ component using OpenGL. But in this case, let me just shut this down, stop the debugging. I'm going to just kill this. OK, so the Android emulator, any of you guys who have built a mobile application across iOS, Android, or Windows today, especially those of you who have done Android development, are probably familiar with the Android emulators that are out there. For the ones that are available and free, they're pretty slow. And for the ones that are good, they're actually quite expensive. So one of the things that we heard from a lot of Android developers was that we should introduce an Android developer. And that's actually included as part of Visual Studio 2015. So you can go ahead and just get this. Now, you could do all kinds of configurations. You can get whatever is the latest API. This runs on Hyper-V, so it actually is complementary to the Windows Phone emulator. It used to be that you had to do a complete reboot with your reset your BIOS so that you were using the other virtualization technologies. Now this works kind of directly in your app. So what I'm going to do now is I'm just going to take a sample, and in this case, I'm going to take a C++ component, the x86 version of it, and I'm just going to drag and drop an APK directly onto the Android emulator. I did this before. I need to unattach the device. I can't have two instances of ADB running at the same time. Okay, let's restart this. This will take just a second. All right. Once this loads, I can actually just go ahead and drag and drop the APK directly onto the emulator. This is a pretty cool demo. Okay, so now using my touch-enabled PC, I can go ahead and drag and drop this onto the device. That's installed properly. Now I just need to go and launch it. So as you see, this is an OpenGL version of an application running the common kind of My Teapots example. And if I can rotate it and rotate it again, I can spin that, and it's actually pretty responsive. So I get a full experience here. I can even, should be able to, this might be a little bit warm, but I can even do multi-touch, for example, and zoom in and out. Zoom in and out to the application. So the Android emulator is a full image of Android running on your PC, and you can run native applications or Java-based applications, or Xamarin-based applications, or Apache Cordova applications. All right, so with that note, let's jump to Apache Cordova. Now for this, I'm going to jump to this other machine. This is 6, I believe. So one of the things that, sorry, I just need to pull out this USB key. Uh-oh. I think it went to sleep. Okay, there we go. Erica, what is it? Shuttle at 1? I just tried that. There we go. Okay. So one of the things that we're pretty excited about is with the Visual Studio 2015 extension, we now have templates for Ionic and Onsen UI. Have you guys ever heard of Ionic? Anybody here? Onsen UI? Okay, they're pretty good templates for building hybrid applications. So I can build a Cordova application using JavaScript or Apache or TypeScript. How many of you guys have heard of TypeScript before? Great. You should definitely go check out Anders' session tomorrow, where he'll be talking about TypeScript 1.5. I don't have the templates installed on this machine, but if I jump back to this machine real quick, I can show you them working. So if we go to File, New Project. So these are pretty popular UI frameworks for building web-based applications. So as you can see here, this is kind of like a simple to-do list style application. While I'm doing this, I might as well just go ahead and launch it. We can ignore that. And you'll see it running. And in the meantime, I will show you the MyShuttle application as well, the driver version of the application. I can go ahead and launch this in the Ripple emulator, which is a version of Chrome that is optimized for running hybrid applications. So this should run in just a second. And while we're doing that, let's jump back to this application. So for the MyShuttle application for the Cordova app, as you can see, one of the things that we've done between the preview that we launched last fall and the RC that we're launching today is we've actually made it a file-based project system so that it actually mirrors the Cordova project itself. How many of you guys have heard of Apache Cordova before? Okay, how many of you guys have heard of PhoneGap before? Okay, they are actually somewhat one and the same. There are a few differences if you're really, really deeply involved, but for the most part, they refer to the same technology. Apache Cordova is a project that Adobe donated to the Apache Foundation a few years ago now, and it basically does two things. Number one, it abstracts away the notion of the platform-specific packaging technology across iOS, Android, and Windows, so that you as a developer don't have to worry about that quite as much. The other thing that it does is it actually makes it very easy for you to access native device capabilities, and then it normalizes those native APIs across a JavaScript API front end. So I'll show you guys that in just a second. But what you can see here is that the way that this is defined is very much like any kind of web application, but it's the client portion of that web application. So there's a www root, and in it I have CSS, I have scripts, and this is where most of my application is defined. I have, in the CSS, you can see that I'm using less, which is a common CSS preprocessor. And if we go to the scripts and then the typings, you can actually see that I'm using AngularJS in this app. I'm using jQuery in this app. So the point is, for Cordova-based applications, if you're a web developer, this will feel very, very, very familiar to you. You can use the same common web-based frameworks that you're using today. You can use the same common web-based experiences for workflow that you're using today. And so that's how we're defining it. The next thing that I'll show you guys is that for Apache Cordova applications, we have a config file. Now, this is where you define the application-specific information for your app. As you can see here, there is common information per app. But if we go into Windows or Android or iOS, there is some specific information that you need to specify here. But the most important thing is the capability of accessing plugins. Now, the plugins are the way that you can access native device capabilities per device, and then they get normalized. So someone creates a plugin for iOS, Android, and Windows, and then they expose it to this common plugin repository with a common JavaScript API surface area. Now, you can get these from the common repository. In this case, a lot are coming from the Apache Cordova plugins. But you can also get some that are defined. Microsoft has contributed some, Adobe has some, Telerik has some. There is a wide variety of community contributors that are defining these plugins. And in addition to the plugins that are available to the public, I can also define my own plugins. So let's say I had my own sensor that I wanted to use for my application, for my mobile apps. I could actually define that sensor using native code and then be able to access it from a Apache Cordova application. And I can do that with the custom. I can actually go ahead and get something directly off of Git. So next thing I'm going to do is just launch this to the Android emulator, which we already have running. So across all of these experiences, C++, C#, HTML, JavaScript, what we have tried to do is to make sure that there are a common set of characteristics that you guys have come to expect from Visual Studio that are uniform across all of the different technologies, depending on which technology you use, so that you don't have to worry about that. Number one is the acquisition experience. The setup experience is really, really simple for your dev box. Number two, the debugging and editing experience that you guys are used to having in Visual Studio for your code or against Windows applications actually also works against iOS and Android. Doesn't matter which platform you're using. Now, what I'm going to do is go to the debug window. Let's just make it so that you can see these two side by side. And I'm going to go to the DOM Explorer and look at the index.html. And now I can use this select element to just select an element on the screen. That has actually updated the DOM Explorer live, so I'm attached in this debug mode. I can go ahead just so that you guys can see it and make this a little more obvious. And you can see that we have updated the application live in the emulator. Now I can go ahead and just edit this HTML directly, and I can just say no rides. and cursor off, and you actually see that I get that directly updated. So this makes the workflow for developing an application extremely rapid and iterative as you develop your app. I can go ahead and start the service and finish it. And I think I forgot to set a breakpoint on this machine, but if we go ahead and go to the Solution Explorer, if I go into the scripts, let's see. Well, let's skip setting a breakpoint for now. But anyways, the point is that you can actually stop in the debug mode and be able to see your breakpoints and have the rapid debug experience for that as well. Now, the other thing that we've done, and one of the benefits, as you can see, we're hitting the breakpoint now. One of the benefits of having a file-based workflow or a project system for Apache Cordova projects is that you can use all kinds of, NPM or file-based tools against your Apache Cordova project. So if you use gulp or grunt, you can use that in this application. And in fact, we have a brand new JSON editor here. So I can bring up the JSON, and you can actually see here that I can, this is using the TypeScript alpha, but I get statement completion. I should get statement completion. For Angular, it looks like that is not coming up right now. Okay. The point is that you actually get integration with all of these NPM and file system-based experiences. If we go to the gulp file, you can see that, how many of you guys have ever heard of gulp, of those web developers? So I can actually use a gulp file and Bower to get the latest packages that I have a dependency on in my Cordova application. And in fact, I can even go to the task runner. So if I go to Tools, let's see, View. If I go to Other Windows, I can actually see the Task Runner Explorer. And you can see that this is bound. This is a way that I can visualize the task runners that are attached via my gulp file in Visual Studio. So if I build this, you can see that it actually runs the before build process. So I actually have the same workflow across with the frameworks and with the gulp file or Bower or whatever actually running in the context of Visual Studio. So this is a very, very kind of productive environment. Now, the next thing I'm going to do is to show you guys the Application Insights integration. So if we go back to the config file here, let's just close this. One of the things I can do, we have been working on a Apache App Insights plugin for Apache Cordova applications, and we have that available as a Git on the Git repository here. One of the things I can do is just take this address right here and copy it and paste it directly into my Visual Studio solution. So I can go to Custom, go to Git, and I can go ahead and paste that and hit Go. This is OK. I don't need to run the application anymore. Let's close this. Doesn't look like the download is working, but basically that is how I would be able to attach to the Git repository to get this App Insights app. Now what I'm going to do is show you what that does. There's a little bit of code that I have to do to create the custom events, but everything else that you're going to see here comes automatically. So if I go to https portal.azure.com, I am not connected to a network. That's great. That would explain a lot. OK, let's try this again. There we go. Now, I'm just going to continue there. And this should be the same password So now we can see the App Insights, which we just announced today is available for public beta. Marav is up here, so if you have any questions, you can come up and ask her about that. And what I'm going to do is go into my Azure account and see what data I'm getting back for this application that's deployed into the wild. It does not look to be here, so I'm going to switch to this machine again. Ooh. I know it was working on this machine, so we'll bring it up here. Okay, you can see that I'm logged in here, and we see that the myshuttle.cordova application is there. Now, there's a number of things that come automatically for mobile applications if you use App Insights or Application Insights. First of all, sessions, page views. We've done some work to integrate crashes here, and this is from the Hockey app acquisition that we did earlier. You can also see that I can see the top devices. So if I go into top devices, you can actually see that I can see all of the different device models that are using my application. So this is iPhone 6, Surface Pro, the different operating systems that are running my app. And then the other thing that I can do is look at custom events. So as I mentioned earlier, and there will be some deep dives on this, I can actually create my own custom code to complete a journey, for example, and track that task and see what happens with that task. So in this case, you can see that I have 112 people have completed the journey. I actually know how many of them are on which version of the application. So one of the things that I heard from a customer just the other day was that they just don't have any idea which version of the application most of their users are actually running. The other thing I can do is actually add a chart here. So I can come into App Insights, add a chart, and go down here and just click on the trip cost. And you can see that in just a second, it will update to show me what the average trip cost was across all of the different users of this application. So that's a pretty cool feature. It gives you insight into both the usage, what mobile devices they're running on, as well as custom insight into the different workflows that they went through in the application. All right, I think that is the end of my demos. So I'm going to kind of jump back to the slides real quick. PowerPoint. OK, so with Xamarin, you can basically build rich native applications across multiple platforms, Windows, iOS, and Android, and you can reuse the code across all of those different solutions. You share the app logic across the different platforms, and using .NET portable class libraries, you can actually share the exact same binaries. You can share the unit testing and things like that. And 100% of the APIs are exposed. So our good friends at Xamarin are very, very, very good about releasing updates to the SDKs as soon as the operating systems release updates to their APIs. In terms of UI design, as I showed you guys, we have WYSIWYG designers directly in Visual Studio so that you can do drag and drop kinds of app construction for your app. And the way that the Xamarin apps are produced is that they actually end up with essentially natively compiled applications running on iOS and Android. So for iOS, it does ahead-of-time compilation to produce the ARM binary, which is basically what the iOS apps do. And for Android, it uses the just-in-time compilation on the Android device. Across the Windows Universal apps, you can share your XAML across all of the different devices. And then you can tailor the experience for each of the devices. For the cross-platform C++ components, you can actually build a shared component, or as Ankit will show you later today, I believe, he will show you that you can actually build entirely native activities in C++ using Visual Studio. And then you can take those shared components and build the presentation tier in Xamarin or Cordova. The Visual Studio emulator for Android is a fast x86 image, and it runs on Hyper-V. So you don't need to reboot to BIOS to get this to work. And it comes with Visual Studio. As you guys know, we have the Visual Studio community version, so you can actually get that for free. and the Visual Studio emulator is included as part of that. It speaks Android debugging, so I don't need to do any kind of custom thing or get another tool to be able to attach in a debugger for that. And I get all of the native device capabilities and sensors in that emulator. The Apache Cordova tools make it easy to build hybrid HTML-based applications. So basically, this is a JavaScript, HTML, or TypeScript, and CSS application that you end up building, and then it gets packaged as a native app for each one of the different platforms. So you can send push notifications, and you can get all kinds of real-time information from the sensors on the device. And then with TypeScript, which if you're a JavaScript developer today and you have not heard or tried TypeScript yet, I highly encourage you to go to Ender's session tomorrow. We introduced TypeScript because as we heard from a lot of customers who were starting to build very, very large web applications with hundreds of thousands of lines of code, was that it was hard to manage JavaScript applications that are of that size. And so TypeScript adds strong typing to JavaScript so that you can get the code productivity that you get in C#, but for JavaScript-based applications. So that's what TypeScript is. And the TypeScript experience is throughout our Cordova tooling so that you get great IntelliSense for all of the plugin completion or for any of the native device capabilities. With the Cordova applications and the tooling in Visual Studio, you can use any JavaScript framework that you use in your web development today, or common command line tools like NPM, Grunt, Gulp, Bower, all of those kinds of task runner kinds of tools. And you end up building a single hybrid application across iOS, Android, and Windows. Now, this was intended to be an overview session so that you guys could see everything that we had to offer in terms of cross-platform mobile development. What I've done here is I've highlighted a couple of sessions that will go deeper on each one of these topics. So if you want to hear more about the app service, there are a bunch of sessions on that. If you want to hear more about cross-platform C++, more sessions on that. Cordova, more sessions. Xamarin, more sessions. So this is the overview session. If you want to go deep on any of these topics, I highly encourage you to check that out. And in terms of resources, you guys can go get these bits today. Go try it now. So go get Visual Studio 2015 RC. Go try the app service on the website that I showed you guys. And definitely try the Application Insights beta. That wasn't quite public yet, so there was no link to send them to, but definitely go check that out as well. And again, please do fill out an eval. So thank you very much.